All right, we're going to continue on with our triangles and talking about similarity. And today we have the side splitter theorem. It says if a line is parallel to one side of a triangle and intersects the other two sides, then the triangles are similar. So let's think about what's going on in this picture right here. If these two lines are parallel to each other, then that must mean this is a transversal. And if that's a transversal, then these two angles are corresponding angles, which means they're congruent. Now you could also do that with the other side and say that these two angles are corresponding angles, so they're congruent. And then we know that both triangles share L as an angle. So this is why if you have a base that is parallel to another line inside of a triangle, then that means you can use the side splitter theorem. Now I will tell you, you do not always have to use the side splitter theorem. You can always do big triangle, little triangle. So this is just a shortcut today. This is just a shortcut. So using the side splitter theorem, that means that side LO over side OP, notice we're splitting the side, equals LA over AR. So you can use this as long as the base is parallel to a line inside of the triangle. But watch out. This only works if the sides are being split. I'm going to write something in red here, and you don't need to write it down. If I say this is 4, and this is 8, and this is x, and this is, I don't know, 7, right there, you absolutely cannot tell me that x over 7 equals 4 over 8. And the reason why is, look at 4 and 8. Are they a side? They're a base. Okay, this is a base, this is a base. You cannot use this theorem. Now here's the deal. Some students don't like it when we have a shortcut and then there's an exception to it and it just makes it confusing for them. So if you are one of those people, if this is too confusing, you can still do big triangle, little triangle, and work it out that way. It'll still give you the same answer. Now I'm going to use side splitter theorem when I can because it's a shortcut, but you can always do big triangle, little triangle, and get the same answer today. All right? So let's go ahead and move down here. We have 1 and 2. Now I'm going to actually start with number 2. On number 2, we see that this base and this base is parallel. So that must mean that 1 over 4 would be equal to 2 over x. And that's because we're doing side splitter because these two are parallel. You are more than welcome to do big triangle, little triangle here. You'll get the same answer. It'll just be a longer problem for you. So we do cross multiplication. 1 times x is 1x, and 4 times 2 is 8. So that's it. Nothing to solve here. X equals 8. That's your answer. I'm going to have you all do number 1 and bring that into class. So have number 1 completed before I see you the next time you're in class. And let's look at number 3. Now, what do you notice about number 2 and number 3 that's different? You should notice that in number 3, not only do we have an x and a y, we also have some labels on our bases. Remember, if we're using bases, we cannot use the side splitter theorem. So, can't use side splitter. Now, technically, you just can't use it to find x. You could use side splitter to find y, but I figure if we have to do big triangle, little triangle to find x, we might as well just do big triangle, little triangle to do the entire problem. So here's our small triangle, 3, 6, and y. And then we have our larger triangle. Over here, this side length is 3 and 4. So 3 plus 4 is going to give us 7. And over here, this side length is y and 8. So just like we added 3 and 4 on the left side, we're going to add our y and 8 on this side. And then don't forget your x here on the bottom. Okay, now that we have this, we can set up our proportions. So 3 over 7 equals y over y plus 8, which equals 6 over x. I'm going to use 3 over 7 to find both x and y. So this is like what we were doing earlier in the chapter last week when we were working out our x and y. So we have 3 over 7 equals y over y plus 8. And then once we get there, we cross multiply. So 3 times y plus 8 equals 7 times y. From there we distribute, so 3y plus 24 equals 7y. And from here we want to get all our y's on one side. So I'm going to subtract 3y from both sides, and I get 24 equals 4y. 4 times y. The inverse of multiplication is division, so we divide both sides by 4, and we have 6 as our answer for y. Now we also have to solve for x, so I'm still going to use 3 over 7, and I'm going to set that equal to 6 over x. From here, we're going to cross multiply, so we'll have 3 times x equals 7 times 6. 3 times x equals 7 times 6. So we'll have 3x equals, and then 7 times 6 is 42. 3 times x, the inverse is division, so divide both sides by 3, and 42 divided by 3 gives us 14. And we're all done. We found x and we found y. So just be really careful. On number 3, you cannot find x by using the side splitter because 6 and the x are both bases. And be very careful because a lot of students continue to try to use it anyway. All right, so let's go ahead and move down to the back side here. Complete each proportion with the correct segment. Okay, so let's see if we can work out this first one. We have GI over IS equals what over HT? So look at this picture. We're going to match up what goes with GI. And if you think it's GH, you are correct. So our answer here is GH. Okay, let's move to this one to the right. It says GH over well, we don't know. There's nothing there. So we'll just leave the GH like that, and then I'll change colors. Let's do IH over TS. Oh, we went backwards. Did you notice that? We went this way and then that way. Okay, so GH goes with IH as what goes with TS? Well, if you think about big triangle, little triangle, it looks like we need this side right here, because then this would be the side of the small triangle, base of the small triangle, side of the large triangle, base of the large triangle. But notice that they went this way with it, right? So if we went this way with the small triangle, we need to go this way with the large triangle. It's a little tricky, so this one is going to be TG. All right, let's go on to the next one. GI over GS equals GH over what? We'll try to match it up with the left-hand side of the picture, and you'll get GT. Erase those. IH over ST equals what over GS? This one can be tricky, but you need to view it as big triangle, little triangle. So we have the side and the base of the big triangle, so we need the side and the base of the small triangle. So we're going to want to use GI in this problem, like that. All right, now let's talk about our one last thing, midsegment. A line inside of a triangle that's parallel to the base and connects the midpoint of the sides of the triangle. And because of those properties, we have this awesome formula here. Now, you can use 1/2 or you can use 0.5. I don't care at all. Whatever works for you. So let me tell you what to do on this first problem here. First, identify where the midsegment is. So it's the line inside connecting the midpoints. And then identify where the base is. And that would be the bottom part of our triangle. Now the formula says that the midsegment is 1/2 or 0.5 of the base. So if we know the midsegment is 1/2 or 0.5 of the base, we know in our picture x is our midsegment and our base is 22. So x equals 0.5 times 22. And when you work that out into the calculator, you end up getting 11. And you're done. If you could work out 2 for class and bring that in, I will be going over it in class, so make sure you have number 2 done for us. Let's look at this last problem. This is our midsegment, and this is our base. And we know that the midsegment is 1/2 of the base. So MS equals 0.5 times the base. Our midsegment in this picture is not a number or not just a letter, it's a number and a letter. It's an expression. So x plus 4 is our midsegment, and we know that that's 0.5 or half of our base, which in this case is 14. So first, find out what 0.5 times 14 is, and it is 7. Then to get x alone, we would have to do the inverse of adding 4, which would be subtracting 4. So if we subtract it, we end up getting 3. All right, that concludes this entire chapter for us. So go ahead and have those problems filled in, and I will see you in class. Bye-bye.